A lot of the questions we get in the book are concerning sequences or series. If we look here, we've got a number of pictures, and each of these pictures has a number. The number of picture 1 is 1, the number of the second picture in the series is number 2, and the number of the third picture in the series is number 3. So this number here often just represents which picture number we're talking about. In this particular one, we also have the number of rings that are in our picture. And we can see that in the first picture, if we count up the number of rings, we have 5. In the second picture, we have 7 rings. And in the third picture, we have 9. So finding the connection, if we're going this way around, along as each time, is pretty easy. Here we are getting 2 new rings every single picture. Here we are increasing the picture number by 1 with every picture. And here we can also quite easily see a pattern between the number of places that the rings intersect. We have an intersect point 1, 2, 3, 4, 5, 6, 7, 8. Every ring cuts at 2 places overlapping the adjacent ring. So there are 8 intersection points in the first picture. We add 2 new rings, which give us 4 more intersection points in the second picture, and another 2 more rings in the third picture with another 4 intersection points. So we can see that intersection points adds by +4. This is quite useful if we're just asking you to determine how many rings or how many intersections in picture 4 or picture 5 to know and identify this pattern. But what we really want to be able to do in maths is not think so very much about this pattern here, but wonder, how can I get from the picture number to the number of rings going this way? So that if I was to ask you how many rings there would be in picture number 120, you don't have to add 2 to 5 120 times. You need to find the connection this way, from n, the number of picture, to r, the number of rings. So we want to see if we can try and get a correlation here. The easiest way to try and do that is to think, okay, how many rings did I actually start with? Well, I started with, and I'll colour them in yellow, I started off here with 3 rings. And then every time I added 2 new rings. So what I've done is I have started with 3 rings, so I would add 3. And for every picture number, I have added 2 lots of rings. So 2 times the picture number plus 3 would give me the rings in the first picture. Would this give me the same connection, the correct connection, in the second picture as well? Well, I have the number 2 here, so I started again with these 3 rings, and now I've got picture number 2, so the connection between picture number would be 2n plus 3. Well, n in this picture is 2, so 2 times 2 plus 3 would give me 7, which is what I want to get here, so this is correct. And if we look back in this one, 2 times 1 plus 3 would be 7. So the clue here for working out this formula is look at the number of rings that you started with. In this case, it was these 3 here. That becomes your plus number here, the one that you add at the end or start with at the beginning. And then the amount that you add each time, you connect then to the picture number. I'm adding 2 rings, so I want 2 times n. Let's see if our formula works then. We now, in picture number 3, have 9 rings. Let's use our formula of 2n plus 3. In picture number 3, n equals 3, so 2 times 3 plus 3. 2 times 3 is 6, and 6 plus 3 is 9. So we have identified the formula connecting number of rings r equals rings is connected by the formula 2n plus 3. So in picture number 120, if n equals 120, the number of rings in that picture would be pretty easy for us to work out. 2 times 120, that's our picture number now, plus 3. 2 times 120 is 240, plus 3 equals 243. So if we had picture number 120, and we went through and we added it all up, we would have 243 rings in that particular picture. So this technique of going downwards is extremely useful, trying to find the connection between the picture number and whatever it is you're trying to find out, in this particular case, number of rings. Let's rub this out then, and instead look at the intersection points, the number of intersection points. How will we find the correlation or the connection between the number of rings and the intersection points? Number of rings and the intersection point. Number of rings and the intersection point. So this connection is what we would now like to try and determine. Just rub all of this out. So if we're trying to find the number of intersection points, we do the same thing. We try and think about how many rings did I have, how many intersection points did I have before I even started adding any rings? Well, I had one here, one here, one here, and one here. So 4 intersection points. So I'm going to have plus 4 here as my answer. And then how many do I add every time I add 2 rings? Well, I add 1, 2, 3, 4. So I add 4 times whatever my figure number is, 4n plus 4. 4n plus 4. So let's see if that formula works. My starting number plus the number that I'm adding every time I add 2 rings. Well, 4n plus 4 would be 4 times 1 plus 4. Give me 4 plus 4 equals 8. So that works for the first one. Let's double check that our formula works for the second one. 4n plus 4. 4 times 2 plus 4. 4 times 2 is 8. 8 plus 4 is 12. 4n plus 3. 4n plus 4. 3 is, n is 3 in this case. 4 times 3 plus 4. 4 3s are 12, plus 4 equals 16. So we found a good formula for the number of intersection points using the same method as before. First we look at where we had the first intersect points in our starting figure, and then we looked at how many intersection points were added each time. So in figure number 2 we started with all of these ones from figure number 1, and then we added 2 more. So 4n plus 4 gives us, so now if we wonder, okay, how many intersection points would there be in figure number 120 if n equals 120? The number of intersection points in all of those rings would be 4n plus 4. 4 times 120 plus 4 equals, well, 4 12s are 48. 480 plus 4 would be 484 intersection points in figure number 120. And we could also go vice versa. And we could say, if the intersection points equals 484, what is the figure number? So we know then, we have our formula that 4n plus 4 is equal to intersection. But we know that the intersection equals 484. So what do we do first? Well, we have all the numbers on one side and all the letters on the other. So we would rewrite this equation as 4n equals 484 minus 4, which equals 480. So if 4n equals 480, n must equal 480 divided by 4, which equals 120. So in the picture that has 484 intersection points, we would have picture number 120 as our figure number.